I'm Anil Kumar, and now let us discuss how to evaluate derivative of a composite function. So the question here is, use chain rule in Lebanese notation to find dy dx at x equals to 1 when y equals to 2u cubed plus 3u square and u is equal to x plus square root of x. So what we have learned is that dy dx, if we are given y in terms of u, u in terms of x, then y is a function of x, and therefore we can find dy dx. That means rate of change of y with respect to x, and that is equal to rate of change of u with respect to y, right? So we could first differentiate with respect to u and then with respect to x, right? So first we could say dy by du, right, times du dx. So that is the rate of change of y with respect to x, or that is how we will find the derivative of the given function. When I say x equals to 1, then what I'm trying to say here is that in this derivative we will substitute the value x equals to 1 and find the answer. So that is what it is. So let us begin by finding what is dy du and what is du dx. Y is given to us, so we'll find both of them here. So we have y equals to 2u cubed plus 3u square. So dy du is equals to 2 times 3 is 6u square plus 6u. On the other hand, u is equal to, let me use another ink here, u is equal to x plus square root of x. So we can say du dx is 1 plus 1 over 2 square root of x. Correct? Now, we can also write u in terms of x and simplify the first expression dy du. It's a good practice to write them in x only because we need derivative of y with respect to x, right? So in a composite function, we are trying to write y as a function of x, right? So if you change u to x plus square root x, you could write this as 6 u square means x plus square root x whole square plus 6 times u means x plus square root x. Correct. So that is the expression for dy du, right? Now let us write down what is dy dx. So dy dx is the product of dy du and du dx, right? So dy du is this expression, which is 6 times x plus square root of x whole square plus 6 times x plus square root of x, and we'll multiply all this by du dx, which is 1 over 2 square root x. Correct? To find the value of this rate of change at x equals to 1, we can substitute 1 for x and evaluate, right? So what we have here is, now let me rewrite this. So we'll say dy dx at x equals to 1 will be, I'm writing 1 for x, right? So we didn't really simplify the expression. We kept it as such because we just had to evaluate the value, right? At times, you may be required to simplify the expression also. Okay, so let's substitute 1 for x. We get 6 times 1 plus 1 whole square plus 6 times 1 plus 1 times 1 plus 1 over 2 times 1, right? Square root of 1 is 1, correct? That gives us 6 times 1 plus 1 is 2, 2 squared is 4. So we have 6 times 4 is 24. Let me write here 24 plus 6 times 2 is 12 times 1 plus half is, we could have written 3 over 2. So okay, so let me write 1 plus half for the time being, which is 12 plus 24 is 36 times 3 over 2, right? Times 3 over 2, right? So which is 18 times 32 over 2, right? So we could now calculate this answer, which is equals to, so we have 36 times 32 divided by 2. which is equals to 576. So the value of dy dx at x equals to 1 for the given function is equal to 576, right? So that is how you could find the answer. I hope that helps. Thank you and all the best.